The James Webb Space Telescope has essentially provided the clearest image of Proxima B ever captured, offering remarkable insights into a potentially habitable exoplanet. This discovery invites us on an exciting journey through space to uncover the mysteries of Proxima B and determine if it could be the next Earth, a place we might one day venture into the vast cosmos. Proxima B exists in the habitable zone of its star, Proxima Centauri. However, this planet is far from an ordinary rock. Proxima B resides just 42 light-years away from us and is shrouded in enigma and wonder. Could it be another Earth, complete with oceans and thriving life? But wait, there's more. Proxima Centauri B isn't alone in its solar system. It also has a companion, Proxima Centauri C, and there could be other hidden mysteries within this system that we have yet to uncover. Proxima Centauri is remarkable in that it generates roughly the same amount of energy from its star as Earth does from the Sun. Could this truly indicate that there is water on its surface, perhaps even life? As we venture beyond our own solar system, we encounter a completely new realm of exoplanets. Planets that orbit stars other than our Sun. With over 200 billion stars in the universe, the possibilities for exoplanets are endless. Some exoplanets even roam freely through space, unbound to any star, like cosmic wanderers. Among them, Proxima Centauri B stands out as a particularly fascinating and alluring planet, with a year that lasts only 112 Earth days and a distance from its star that places it closer than Earth is to our Sun. In fact, one side of the planet is constantly bathed in sunlight while the other side remains in perpetual darkness. Now, let's take a closer look at Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri B. These two stars form a binary system known as Alpha Centauri A and B and are the third brightest stars in the night sky. With a luminosity of just under 2.7 times that of our Sun, Proxima Centauri, also called Alpha Centauri C, is a red dwarf star located 21 light-years away from the other two stars. It is the closest star to Earth, and the term Proxima means closest star in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn, Proxima Centauri is not visible to the naked eye due to its faintness, with an apparent magnitude of 11.13, much dimmer than the human eye's limit of 6.5. Despite being our closest celestial neighbor, Proxima Centauri is still an intriguing star to study. Red dwarfs like Proxima Centauri are highly efficient in energy production, not producing vast amounts of energy but maintaining luminosity for trillions of years due to their internal convection processes. Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of red dwarf stars, including Proxima Centauri, is still debated. For instance, Proxima Centauri is a flare star, meaning it experiences frequent and intense bursts of radiation. Additionally, because of its low mass, its habitable zone would be much closer to the star, estimated to range from 0.23 to 54 cents. But Proxima Centauri B's habitability is questionable, as it is frequently bombarded by intense ultraviolet radiation, far stronger than what we experience from our Sun. This radiation is so harsh that even light hydrogen particles are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet resides within the habitable zone of its star doesn't necessarily mean it can support life. Proxima Centauri B may not even have a stable atmosphere, which is crucial for regulating temperature and maintaining a water-friendly surface. Without it, any potential life would be vulnerable to extreme space weather, making the planet inhospitable. Although Proxima B may seem Earth-like at first glance, it is far from being suitable for life. Scientists remain cautious, recognizing many factors that could make the planet uninhabitable. The search to uncover the truth about Proxima B continues, and some scientists are still hopeful. One tool that has captured the attention of astronomers is the James Webb Space Telescope. After years of anticipation, the telescope was launched in 2018 and is helping us determine if life could exist on Proxima B. However, as with all scientific endeavors, there are challenges to consider. Numerous adjustments were necessary to ensure the James Webb Telescope delivers precise images. As astrophysicist Abby Tabor from Harvard explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared radiation. The James Webb Space Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation from the planet's surface and look for patterns that might indicate water or an atmosphere. But what if the planet has an atmosphere that isn't conducive to life? The presence of an atmosphere doesn't guarantee that life exists, cautions astrophysicist Ed Turner of Princeton University. Proxima Centauri B might have an atmosphere as dense as Venus, which would result in extreme temperatures too harsh for life to thrive. The journey to unravel Proxima B's mysteries is filled with obstacles, and while the James Webb Space Telescope offers great promise, there are additional challenges to consider. With mounting costs, space scientists feel the pressure to discover ways to observe planets like Proxima B, but the potential rewards are immense. The chance to explore unknown worlds and uncover the secrets of distant planets that might harbor life is a pursuit worth following. If Proxima B were indeed habitable, could we one day visit it? It's the closest exoplanet to Earth, which makes it especially intriguing, practically like exploring our own backyard. What makes it even more exciting is that Proxima B is nearly the same size as Earth and lies in the habitable zone of its star, suggesting it could have conditions favorable for life. Its proximity to Earth makes it an ideal target for the search for life beyond our solar system. Though we cannot reach Proxima B just yet, it's certainly on the radar for future missions. As technology advances, exploring this Earth-like exoplanet could one day be within our reach. However, such a journey would be a formidable challenge. For instance, it would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, an innovative solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system, and along with it, Proxima Centauri. This technology harnesses solar pressure to keep the spacecraft on course, eliminating the issue of fuel depletion. What's even more fascinating is that this cutting-edge technology could provide valuable insights into the potential for life on other planets like Proxima B. However, as with any ambitious endeavor, there are limitations. The presence of an atmosphere does not automatically imply the presence of life, and Proxima B could end up resembling Venus with its thick, hostile atmosphere. Moreover, the James Webb Space Telescope can detect infrared emissions from Proxima B if they reach a brightness of just 5% of the daytime side's light. While 5% might seem like a small figure, when dealing with a star much dimmer than our Sun, this is quite significant. If Proxima B has advanced civilizations, they may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super-Jupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine seeing such a planet up close, with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri B isn't alone. It has a companion, Proxima Centauri C, which is much farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more interesting about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be called Proxima Centauri D and will be roughly the size of Mercury or Mars. Imagine a life where the night sky is filled with stars, as well as countless other planets, each with its own unique characteristics and orbits. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time to be a space scientist. While we don't yet have an accurate count of exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a fascinating glimpse into the attributes and composition of these distant worlds. Exoplanet planets are most commonly found through the changes they induce in their host stars. The gravitational pull of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets, like those in our solar system, can also have natural satellites known as exomoons. With more than 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets remain to be discovered. NASA's James Webb Telescope is unveiling the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a sun-like star 700 light-years away, and this finding marks a significant step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we've never seen before, sparking excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering data about the universe in the infrared. The light from the young emitting object known as 110 IROS 4 illuminates the cool, wispy cloud material, and the orange spots behind the cloud reveal light from distant stars obscured by the ice in the cloud. This remarkable research was part of Webb's Ice Age project, which aims to study the formation of ice from its creation to the development of icy comets. And that's not all. The James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared.